Welcome back to Magnum Projects. Today we are back on this 360 Magnum build for the 73 Dart that we're working on. Last time we were on this thing, we got the rotating assembly all put together, new pistons, cleaned up crank and everything. This time we're going to be building it up, hopefully the rest of the way. So let's start diving in. We got plenty of goodies up on the table. So we'll start off with our camshaft. It's just kind of a street performance comp cams for the 360 Magnum and 318, pretty much just small blocks. There's the cam car if you're interested. This engine, I'm sure I've mentioned it, it's just going to be kind of a, you know, a nice stout street motor. This cam is going to do everything we need it to. It should give us a little bit of idle lope. This is going to be our first step. We need to get this in, get the timing set on, and then we can move on from there. So one important check to do before we put our camshaft in is we want to make sure all of our lifter bores are free and clear of any grime or surface rust, anything that inhibits the lifter from moving up and down. It's less critical in a roller lifter setup because you don't want the lifter to spin. In a flat tappet setup, the lifter has to spin or else it gets eaten, and that's where it's super critical. You have to make sure the lifter spins totally freely. It's still important to check on these roller lifter motors. So no oil. It should drop down easy. See, there's zero hangups. I'm going to go through and check all of these, make sure they're all good. If you do end up having some kind of hang up, which ideally you check this before you have everything assembled, but I already checked these bores and they're all clean, so I don't expect this to have any hang up. If you do have any issues, you want to use just like a little wheel cylinder hone like you use for rebuilding brake cylinders, and just run it through there real quick, and that should clean up any issues. It's a little sticky with oil, that's why it's hanging up. Simply lube in that one. As long as it falls through the bore with gravity, you should be okay. We're looking all good there. Alright, now we're ready to slide our camshaft in. It can be helpful to do this before the crank, just because you can reach at it from under and kind of support it. But what I do is I just thread a bolt in, give us a little bit more leverage. Since this is just a standard roller cam, we don't need any kind of special lubricant, just normal engine oil or break-in lube like this. Not break-in lube, assembly lube will be fine. Now we just got to be very careful not to nick our cam bearings as we go through. It'll be kind of tricky. Once we're over to here, we can use our hand again. And in we go. Make sure we turn nice and easy. There's going to be some drag because of the assembly lube, but we're turning real smooth. If it binds up or anything like that, you have some kind of issue with the cam bearings. Alright, so we can take this bolt off, and then next up is our cam thrust plate. This thing keeps the cam from walking back and forth. Good to lube this up a little bit since the cam rides up against it. Then I like to use a little bit of Loctite on the bolts just because, I mean, you don't need to, but these small bolts, it keeps them from backing out, so might as well. Funny story, a few years back I was working on a 66 Mustang, if I remember right, with a 302 that a guy and his friend had put back together after getting it back from the machine shop. And he had just restored this 66 Mustang. It was cherry, and it was running like garbage, total garbage. And he called me in to help, which, funny enough, he's actually an old school teacher of mine. But they couldn't figure it out. I couldn't figure it out right away. The ignition timing was jumping around like crazy. It was just garbage. I thought the cam, well, I knew there was some kind of issue with the cam because any kind of jumpy ignition timing usually relates to some kind of cam issue. And eventually I pulled the engine out because I figured the cam is messed up in some way, and turns out they forgot the cam thrust plate, so the cam was walking back and forth, and obviously the way the gears mesh on the distributor and the cam, that's going to advance and retard the timing randomly. So all that to say, don't forget that, because it's actually there for a reason. Who would have guessed? We've got this little oil deflector. Might as well put that back on. And these half-inch bolts have a torque spec of 210 inch-pounds, which is right around 17 foot-pounds. Basically just tight. So next up is going to be our timing set. So we're going to take our crank bolt out. Just going with the standard Melling double roller chain setup. So the crank gear has 3 different notches. We're going to go for the 0. You can see there's an A and R here. Advance and retard. That's like a ton of degrees. That's what, 240 degrees? I don't know why they grind those in. I don't know if there's a factory cam that uses them. Looks like we're also missing the key for the camshaft. Alright, so here's our cam key. I'm surprised they didn't come with one, but I don't see it in the box. This is the old one. Just tap around home. Gonna have to gently use a metal hammer. Should kind of self-center, it's half moon shaped. Make sure our cam gear will slide on nice and easy. Yep, no worries there. Alright, so it works pretty much just like any other V8 from the era. You just line up dot to dot. Trickiest thing is you just got to make sure you're at the same depth, top and bottom. There we go. Alrighty, there we go. A little bit of a edge you gotta get over. You see we are aligned dot to dot. I think we're not quite at top dead center, which is why they're just a little bit off, but if you're a tooth off, like the dot will be like over here or over here. It's a pretty big difference, so we are looking good there. Now, a lot of guys at this point go ahead and do a full degreeing on the cam. Personally, yeah, if you're doing a race motor and you want to get every ounce out of it, yeah, that's important. This is just going to be a street motor. We're good to just send her in. These cams are ground with, I think, 3-ish degrees of advance, which is totally fine for us. That makes it a little bit, that brings the power curve a little bit lower, a little more torquey, which is perfect. That's what we want. So we're just going to go ahead and leave it as is. Alright, so now our cam bolt. I like to use a dab of Loctite here as well. Torque spec on this is 50 foot-pounds. And how I like to torque this is thread a couple flex plate bolts into the back of the crank, lock it in place with a pry bar between the bolts, and torque her home. So that's what we'll do. There we go. I'm going to thread our crank bolt in, and spin her around, make sure everything's spinning freely still. Should be, but always good to do a sanity check. Alright, and that should put us right back at top dead center. Now we can move on to our lifters. So we're going to just stick with the stock roller lifter setup. There's nothing wrong with it. It's got that spider that goes over all of these, and it uses the link bars. I'm going to go ahead and replace our lifters. Going with Sealed Power, Federal Mogul, any of their subsidiaries I've never had an issue with, so I like to go with them. So these are just the stock Mopar style roller lifters. We'll give them a good coating and assembly lube, drop them down into their bore, do that over and over. We'll do that all the way through, and then we'll get our link bars on. Now, I've heard a lot of guys for some reason say that you have to soak these in oil overnight or pump them up with oil. My opinion is that's all just bunk. There's no reason to do that. In fact, I think hydraulic lifters should be installed dry so that you can actually set preload properly. If you soak them in oil and pump them up and everything, you're going to run into issues, but hey, that's just my opinion. Alright, so here's one of the cleaned up stock links for the rollers. A lot of people call them dog bones because they kind of look like a dog bone. So they just kind of go on like this, and they make sure that the roller stays aligned properly. So I'll go through and set them all down. All right, now we can put our mostly clean spider back on. So all this does is it just keeps these dog bones from popping off. Otherwise, you wipe a cam lobe. So it should only go on one way. Just make sure all the little spring fingers stick out over where they need to go. Then we got these 3 bolts. I like to Loctite them. We'll just snug them on up. And these don't need to be crazy tight, just, you know, torqued. Now cam and lifters are in and secured. Alrighty, so for our top end, we're going with these aftermarket aluminum heads. These are Speedmasters. I was planning on going with the Edelbrock ones, but their combustion chambers are just really small. I think they're like 56 or 58 cc, something like that. And that would push us like almost past 11 to 1, which is not where we want to be. With these, I believe these have a 64 cc chamber, if I'm remembering correctly. And the calculator tells us we are exactly dead on at 10 to 1, which is perfect. That's where we want to be. Pretty big valves. Definitely going to be a step up from stock. These are CNC ported. They're just China castings that they take and they make a CNC program for. So they should be good enough for what we're doing. Really, the ports are pretty dang good, honestly. The port job, can't complain about that one bit. That is a really good open path compared to stock. See, there's a little bit of roughness on the ports just from the CNC job, but that's not going to affect us at all. In fact, it'll probably even help. You don't want super mirror smooth ports. Now, one little hang up on these is they are LA style heads. They take the shaft mount rockers and they're oil through head. We're using a Magnum block. They don't have the oil ports in the block. You can drill them out, but decided to go with these matching Speedmaster rockers, which hopefully are good enough. These supposedly will oil through pushrod and then oil the rest of the shaft. You can see in the pushrod cup they've got a little oil hole. So that should hopefully take care of top end oiling for us. We need to check our piston to valve clearance and also our pushrod length since we're changing basically all the top end. So we're going to go ahead and get our head studs on and then we can start checking. So when we're changing all this stuff, it's definitely important to do all the checking you can. Pushrod length is a must. There's no way the stock pushrods are going to be right for this. I mean, if they are, it'd be nice, but highly doubt it. And piston valve clearance is another important one. We're probably more than likely going to be totally fine. Well, actually, I'm sure we're going to be fine. But it's good to check because these pistons obviously are different from stock. But we're not using a very aggressive cam. We're not doing tons of lift, so we should be A-okay, but we'll still check. So those heads take these specific Speedmaster studs. There are 3 different lengths. Obviously, our shortest ones go here on the bottom. Then our medium on the corners. Next the longest, then a medium, then the longest, then a medium. So we just stagger like that. Now we can get one of our head gaskets on. Let's see. Check for any directional markings, which I don't see. There we go. It only sits on one way because of the dowels. Alright, so before we set our heads on for the testing, we need to remove a couple of the valve springs and replace them with low tension springs so that we can use our adjustable push rod. I've found the easiest way to remove valves is you stuff a rag or something down the bottom there. You get a socket that fits over on top of the retainer with the keepers being able to fit through, and you smack. Although these springs are heavy, so we may not be able to do this very well. Yeah, I think we're just gonna use the standard, but on less heavy-duty springs, that's the way to go. You can just get it one smack. Way easier than having to wrestle with the normal C-clamp type compressor. So we're just gonna use one of these standard valve compressors. Real simple. Alrighty, there we go. Now for our temporary spring. I do have like a Cam's checking spring kit, but I cannot for the life of me find it, so I think this is an old wheel cylinder spring. That'll do it for us, we'll see. Keepers are kind of hanging up in here. There we go. Hopefully there's enough spring pressure. Now we'll do the same for the other one. So this is a spring you actually pick up at Lowe's. I think we're gonna have to cut her down. Or Home Depot, I guess. So I'm gonna snip this to about as tall as the old springs and throw her on. Alright, there's our cut down spring. We may end up wanting to switch this one to the same spring because it's a little bit heavier. In fact, let's do that. It'll help us get a little bit of better witness mark for when we're checking pushrod length. Make another one of those springs and we should be good to go. Here we go. Alright, so now we can set our cylinder head onto the block temporarily. With the studs, we want to be real careful not to drag across the cylinder surface. Alright, so now we'll temporarily put some of our nuts on. So we'll just go ahead and snug these up. Definitely don't need to torque them. We just want the head to be sitting flat. I'll probably throw a couple more on. So here is our adjustable push rod. This is going to let us figure out exactly what length of push rod results in the best geometry. I like these trick flow ones because they have these little dots here. There you go. And every turn is, I forget, 10 thou or something like that. I gotta double check before we start measuring. But you can just drop them down and super easily check how many turns are going, and then you can know exactly what length you need to order to get a good result. So each full rotation is 50 thousandths. So that would be 50. And also you can see every turn one more of these grooves is exposed. So each groove is worth 50 thousandths. So that makes it really easy to measure. So now we can set our rocker assembly on. Unfortunately, I noticed we're actually running into a small issue here. So you can see the rocker arm is interfering with the valve spring retainer. So we're actually going to need to move to some beehive springs, which neck down from the full diameter at the bottom to a nice narrow top, so that we can actually clear these rocker arms. To figure out exactly what springs we need, we're going to need to check our installed height, so we'll do that on the other head. Got the valve springs removed. We're going to take a retainer and the keepers. And a straight edge. And I'm just going to use a caliper to measure all the way to the seat. They do make valve spring micrometers. They're really not that spendy, but I don't have one right now, so we're going to get close enough with calipers. And that measurement is our installed height. We'll use that to figure out which valve springs we need to order, and then we'll swap them out. Alright, so we have our new springs, beehive springs. There's the specs on them. So, if I'm remembering correctly, this has a 1.8 inch installed height. At closed, we should have about 135 pounds of seat pressure, and at our full lift, we should have about 325 pounds of pressure according to the specs on this, which is exactly where we want to be for our mild hydraulic roller setup. So, we also obviously need new retainers. Here's what we went with. It's the perfect diameter for our beehive springs. And these clear beautifully with our rocker arms. So now I'm going to do the tedious process of taking all the old springs out, putting the new ones in, and get back with you guys. One benefit of beehive springs I should mention before we put them in is you can see the original springs are these dual springs with an inner lighter spring that acts as a damper. At higher RPMs, valve springs have weird harmonics, so they'll cause valve float and kind of float open. You don't need the inner spring with a beehive spring because the mass is different along the top and the bottom as you go up and down, since it's necking down. So that actually eliminates any harmonics, and it works just as well as a dual spring, which is kind of neat. So it simplifies everything for us. Alright, we've got all of our new beehive springs on. Of course, we've got our checking springs on for cylinder 1. Let's lay our rockers on and see how we do. You can see with the beehive retainers, we have tons of space to clear our rockers. So we are all good there. Now we can finally move on to checking our pushrod length. So these are shaft mount rockers, obviously, and pushrod length is not such a big deal on these, especially since we have the adjusters, because the pivot point or the fulcrum point of the rockers is fixed. The only way you can change it is by putting shims, and you can only raise it up. And the fulcrum point is actually what changes the wipe pattern. On pedestal rockers, like what you usually have on Fords and Chevys or later small block Mopars, the pushrod length is really critical because it actually changes where the wipe pattern is going to be, and the ideal wipe pattern is going to have the rocker tip moving in the center of the valve stem to eliminate excess valve guide wear. But since that's fixed for us, we are going to kind of be stuck with what it is unless we're going to need to raise our fulcrum point up with shims. We'll see. So right now we're just trying to figure out what pushrod length needs the minimum adjustment from our adjusters on the rocker. So let's go ahead and do that. So let's pop this in. We're going to need to go long, but I like to leave the adjuster end at the bottom so you can see it. And since we're using an LA style head on a Magnum block, we have to use these rockers because they accept oil through the push rods and through the oil holes in the block, which we don't have on a Magnum block. So we have to make sure that the adjuster is within this range without the threads, because what happens is the oil from the push rod comes up through this hole and then feeds through the smaller hole in the threads. If we have the adjuster too far up or too far down, it's not going to get adequate oil. And we are already running into an issue here. It looks like our pushrod holes don't have enough clearance to get our pushrod where it needs to be. You see down here we're actually hitting the aluminum, and we still have a ways to go to line up with the rockers. Alright, so you can see the mismatch between the head gasket and the pushrod hole in the head. Now because we're running the stock Magnum roller lifters with the LA style rockers, we need to open up that hole a little bit with a die grinder. I believe if you were running the taller aftermarket link bar roller lifters, you wouldn't run into this issue because you'd be at a little bit of a better angle. But for us, we're going to need to just use the head gasket as a template. We'll open it up to match the stock pushrod holes on the Magnum heads, and then we should be good. Alright, so to make our clearance, we're going to use our head gasket as a guide since it seems to correspond pretty closely to our interference. And you can see, if we line up the head gasket with the head bolt holes, the material that we need to take off. So to do that, we're just going to use a die grinder with one of these aluminum burrs. And we'll just work away at it, just take a little bit off at a time. This isn't a critical area. It's not like we're going to risk going into a water jacket or into an intake port or anything like that. So it's not critical, but we just need to get enough clearance. So I'm just going to work away on cylinder 1. We'll test fit it, and once we have good clearance through the entire pushrod travel, then we will mirror that over onto all the other cylinders. Alright, so I've got the exhaust clearanced enough for the pushrod. The intake just needs a tiny bit. It pretty much clears from the factory, but it just needs a little bit to get the airspace. The exhaust needed quite a bit of reworking. So now we can check our pushrod length. So we'll just count the amount of rotations, and each one is 50 thousandths. We have our rocker arm adjuster right where we want it to be, ideally. So we'll just start counting. So we're at like 15, just under 16 to get to 0 lash, which is where the push rod's just touching the lifter cup and the rocker cup. So we'll call it 16 there. We can take our push rod out and figure out exactly what length we need to order now. Actually, before we do that, let's transfer this over to the intake side and make sure it's looking like the same length over there. Yep, just about the same. Any difference would just be due to a difference in adjuster height. So we can call it the same for both of those, and we're going to call it the same across the whole valve train since we have some adjustment built in here. Alright, so here's the math we got to do to figure out our push rod length. So we'll start off with what our checker ended up at for 0 lash, and that was 6.6 inches. And then our head gasket's going to compress 5 thousandths according to the Felpro spec. And then we also want about 50 thousandths of lifter preload since we're doing a hydraulic roller. And that puts us right at 6.645 inch pushrod length, which I don't even know if that's an available length, but 6.65 would work fine. We're just going to go for whatever is closest, and we have plenty of adjustment left in the rocker adjusters. So let's get those push rods in order. I'm going to do the clearancing on the rest of the push rod holes and be back when we got the push rods. Alright, so now we've got all the push rod holes elongated. They just need a little bit of clearance, and now they're all good. So now we can finally check our piston to valve clearance. So we're going to be checking with the clay method, is what a lot of people call it. You basically just put some kind of putty on the piston valve reliefs, and we'll run the engine through a full rotation, 2 rotations, and we'll take the cylinder head off, we'll cut the clay in half and see how much of a divot the valve's made in the clay, and we'll use calipers to quantify that, and hopefully we will be within clearance. We're in a really mild setup, so I think we're going to have absolutely 0 issues, but it doesn't hurt to check. One thing to note is we are going to have to swap these lifters out just because they're hydraulic. If we take one of our push rods here, you can see that it's really easy to push the plunger in. That's going to give us a false lift reading because some of the lift is going to be taken up in the hydraulic lifter adjustment. So what we're going to do is we're going to take one of the old lifters, take it apart, take the spring out, and fill it up with washers or whatever we can to lock it out at max adjustment. Alright, so our old lifters actually seem to be pumped up enough that we're not going to get any issues. But if for whatever reason you do need to lock out a lifter, you just pop the circlip or these little metal wires out. The whole thing will pop out. Usually there's a spring inside with the plunger, which is up top. You just fill it with enough washers that fit in there that it holds the plunger all the way tight against the wire clip. So we'll go ahead and take our new lifters out. We're not going to need to put the spider in, just to test. So now we can go ahead and drop the clay onto the piston. Alright, so got our piston clear of any crazy amounts of oil. Take some Play-Doh, purple because it goes faster. Looks way cooler than black or white. Then we'll just kind of fill in the valve reliefs. Let's drop the head on. Just throw some head nuts on, snug them up, just to keep the head from lifting up. We have the checking springs on, so it's not going to be too big of a deal, but definitely don't want the head lifting up. That'll affect our readings. Alright, now throw our push rods in. Lay the rockers on. Snug up our rocker shafts. Alright, now we will adjust the rockers to 0 lash. Alright, now we'll just spin it around a couple times. Make sure we're making a good impression of clay. Now we take it off. Alright, you can see we barely even kissed the Play-Doh, so I think we are more than good, but we'll make a cut halfway through each relief, and then we can see exactly what we're working with distance-wise. We'll just use a razor. Alright, there you go. We don't even need to check our clearance with calipers because we have more than enough. These pistons have a pretty generous valve cutout, valve relief, so we're working with such a mild cam, low compression, low duration, not a huge deal, so we're good to go. If you needed to measure, you would just take calipers while the Play-Doh is still in place and use the backside of the calipers to measure down into the valve relief. And then you would also want to account for the amount of head gasket compression, so you would take away 10 thousandths in our case because the head gasket is going to compress 10 thousandths if I'm remembering correctly, and then you would get your piston valve clearance. It's not going to be accurate to the thousandth obviously, but it'll give you a good idea if you're in the danger zone. We're totally good, so I think we're ready to put our good lifters back in and get the cylinder heads installed once and for all. Alright, so we want to make sure the deck is free of any oil. I went over it with some acetone. We already cleaned it before, so we'd just be double checking. So we'll put our head gasket back on, make sure that we got it properly aligned. Alright, I went ahead and cleaned the cylinder head, especially since we've been using the die grinder on it. When I get all the aluminum chips out, also wipe any oil away from the sealing surface. So now we're ready to go ahead and drop it on down for the last time. Fingers crossed. Also swap the checking springs out, obviously. Now we're ready to go ahead and get our head stud nuts on and torque the cylinder head down. Speedmaster recommends a torque spec of 75 to 80 foot-pounds for the 318 and 85 to 90 foot-pounds for the 340 or 360. I'm not entirely sure why there's different torque specs for the 360 versus the 318, but we will follow the recommendations, so we'll torque this to 85 foot-pounds. We'll just use regular 30 weight. Oil both sides of our washers. Alright, I'll go ahead and run these all down. Alright, now we'll torque at 3 equal steps to 85. We'll start from the center and work our way in a spiral out. We'll go 30 and then 60 and then 85. 60. Finally 85. Now I'm going to do the same exact thing on the other side. Once that's in place, we'll go ahead and get our valve train in. So next up, we're going to need to check and set our rocker side play. You can see we've got way too much at the moment on most of these. These rockers came with shims that we're going to use. We're going to shoot for about 15 thousandths. We'll just use feeler gauges to check. So just to figure out how much we need, right now we're probably at, I don't know, 100 thousandths or something like that. So we'll just take one of these thick ones and shove it in there and check over on this side. We're going to want to try to center the rockers. So we'll try to split the difference and put an equal amount of shims on either side. Okay, that should just about do it. I'm just going to go through and note which shims we need for which, and then we'll take all these off the shaft and put them on the way they need to go. Alright, so now we'll just slide everything off to get to where we need to get to. Now in here we can see the oil through pushrod provisions for these. You can see the hole way down in here. And that hole gets drilled through this way, and we already looked at the adjuster, how it has that cutout for the oiling. And in this hole up here, the oil travels around on this stepped portion of the bushing and then drips out and oils the tip. Now we'll go back on and check our work. Looks like we over shimmed on this one. So I took the one medium shim that we put in out. Same thing over here, which is strange, but that's why we check. Looks like the clearance is too tight on that one. Actually, all of them seem too tight, so we'll take one of the thin shims out of each, except for the one we didn't shim at all. We'll check that one real quick. Yeah, no play. So I'm just going to go back and forth and adjust shims until we get to 15 thousandths on each, and then I'll come back. Now we can go ahead and do our valve adjustment for this side. It's really easy when we can see the valves. How I'd like to do it is whenever one lifter on a cylinder is at full lift, the other one is at base circle. So right now we can adjust this exhaust valve and this exhaust valve. We'll rotate the engine around, and we'll work our way around until we have all of the lifters on this side adjusted. You can also go through and do it with the firing order, because at top dead center compression both valves are closed all the way, but this is easy enough, so that's how I like to do it. What we'll do is we'll loosen the adjuster and spin the push rod while slowly tightening the adjuster until we feel a little bit of drag. That's 0 lash. So the cup on the lifter isn't compressed at all, but the slack in the valve train is all taken up. So from that point, we'll then do 1/2 turn to get lifter preload, and then we'll snug the adjuster down. There we go. Just keep on doing that. So there we go, this whole side's adjusted now. The rockers aren't going to look like they're moving much right now because the plunger on the lifters are going to take up all the movement. But once they pump up, we'll get full lift on the rockers. So now I'll go through and do the exact same procedure on the other side.